Of 2017, this is question 8b on paper 2, junior cert higher level, and this is a question on geometry. So this question says we're asked to find the size of the angle T, and we're asked to show all our working out. So the first thing that I would say, so I'm going to fill in as much as possible that I know first, and then I'm going to maybe see where that leads me. So the first thing I can say is, because this is the radius and this is the radius, so this line is going to be equal to this line. So the radius is just the distance from the center to the edge, and it's always going to be the same. So this means that that's an isosceles triangle, and in an isosceles triangle, the two sides that are equal, well, the angles opposite these sides are also going to be equal. So this angle here is going to be equal to 22. And now I have in my triangle, I know that all angles in a triangle have to add up to 180. So whatever, let's call this A for now, this angle A. So 22 plus 22 plus A is going to have to give me 180. So 44 plus A is going to have to give me 180. So what I have to do now is I can subtract 44 from both sides. So A is going to be 180 minus 44. So A is going to be equal to 136. So I'll just write in 136. So, but this angle here, I know that in a whole rotation, the whole circle, say, it's going to be 360 degrees. So if I want to get what this side on this bit is, I can do 360 minus 136. So it'll be 360 minus 136, which gives me 224 degrees. So now I'm after figuring out that this bit here is 224 degrees. So there is a theorem that's going to help me to find T, but it's kind of presented in a different way usually in the books. So we know that if we have an angle at the center of the circle, and then we have, say if we have an angle then on the circumference. So that's actually a bad diagram. So say if we have an angle at the center and then an angle at our, so just pretend that's a proper circle and it's all drawn with a ruler. So the angle at the center of the circle is always twice the angle at the circumference, as long as they're standing on the same arc. So say we could have another scenario where it could look like, say this is my angle at the center, and then this is my angle at the circumference. So this angle is double whatever this angle is. So they just have to be standing on the same arc. But we could also have one that we're not that used to seeing. So it could be that they both are on the same arc. So it just happens that it's presented differently. So they're literally both on the same arc. They're both on this arc. And whatever this angle is here, that's going to be double whatever this angle is here. And I can see that 224, if I can see that that's on the same arc, so it's on this arc, as this one here. So this is the one at the center, this is the one at the circumference. So T is going to be equal to 224 divided by 2. So 224 divided by 2, which gives me T is going to be equal to 112.